Hello everyone, welcome back to Coding Intuition. Today we are going to solve implement try question on LeetCode. So in this question we have to implement a try. So let us first understand what is try data structure is basically. Let's suppose you have so many strings. For example, here we have taken three strings, and let's assume you have so many strings and you want to search a string from a data structure. Uh, you can have an array or something, but try is an optimal data structure by using which you can very easily search strings, and it has many applications, like whenever you search contacts in your mobile phone, or you do a Google search and that give you recommendations. So that are some kind of applications of these try data structures. So let us first try to understand what is this try data structure and how it is made. So for example, let us take a string. We have a string code. So if we want to insert it in our try data structure, basically this is in a form of tree, and it is also called prefix tree, in which the prefix word stands for something in the prefix of a string, basically. So what we do in this try data structure, first of all we create a root. Let's say we have just added backslash here in the root. After we have created root, whenever we get a word, we create branch for it. For example, we have word code here, so we have added code here, code, as a tree. Okay. And if we have a word which has the similar characters as our previous word, so we can create branches inside those. For example, all the words starting from the C will have a different branches. So for example, we have a cat. If we have a word cat, so it can um, be created here as well. Okay. So that's how we create that is what a try is. It also called as prefix tree. So for example, we had a word apple, so we will create a completely different branch of it. And as we added the word coding, so first three alphabets of word code and coding are similar, so we have taken the similar branch and added ing at a different branch. So that is what a try is. And this data structure can be very useful when searching for a string. So this can be very optimal data structure when searching for a string. So now what this question want us to do, question want us to implement this class which have these functions. So first of all, we have a class try, which will obviously have a constructor which will be used to initialize our try. And first and second thing, we have to write a function called insert, in which we have to insert some words inside our try. Okay. So and another thing we have is we have to search some words in our try. If the words we have inserted, we have to check if these words exist or not. We have to return a boolean according to that. Or we could also search for prefixes. For example, we just want to see if something like app exists our our try. We can do it by this. So that's what we need to do in this question. We need to implement this class which will insert words in try, and search for words in try, and search for prefixes in try. So now let us just quickly move to the solution and try to, first of all, let's try to understand how will we insert value inside our try. So let us so first of all, we need to understand what we will be inserting inside our try. We will be inserting nodes in our try, and each node will have three values. A value of character, basically a character which is inserted inside a try. For example, when C is inserted the try, the value of it will be C. A boolean if it is a if it is a character by which the word is ending. For example, here we have code and it is ending with e. So if we make a node for e, what we will be doing is we will be saying this is a word by which this string is ending. So we will set it as true if it is in last node of a string. Okay. And we will have an array of nodes which is basically the children of each element. For example, the children of C would be O, and the children of D would be E and I. So basically that we will be storing inside the array of nodes. And one thing to notice, that the size of this array would be 26, because we have given in the question that we will only have um, lowercase English alphabets inside our string. So if we have only lowercase English alphabets, we can only have 26 possibilities of for any child. Okay. So that's why we have taken the size of the array as 26. So first of all, what we will be doing is we will be create a node for this for our root. So let us see here that first of all we will create a node which will be containing our backslash. So first of all, we will add backslash inside our node, and value of backslash will be this. It ends with nothing, so it is false. And first of all, the complete children array will be initialized with all null values. This stars here, you can say, representing null values. So first of all the values will be null. And as soon as we insert a word called code inside our try, so what we will be doing then, so we will be saying if there is something at value 2. So basically this is how it works. There we have 26 values uh, in our English alphabets in small alphabet. So first 0 will represent A and 1 will represent B and so on. So we will check if C already exists as a children of of this value. If C already exists as a children of backslash, we will say continue, go to the next children. Okay, and I will show you in code how we'll be doing that. So here we have C inside the children of our root, and if whenever we will be adding apple, so we will also add the children here, that yes, we have the children apple here, and this C is not an character here, this is basically a node. So we have added the node C here. So whenever we create we will create a node C. So now we have created a node C here, and we will initialize everything to null here first of all. And whenever we go to our next value of C, so we will iterate through all of this string when we are inserting it. So now we come to O. So and we will set our current node to this node. So now we will check if at the 14th position, basically the position of O will be this, and if at this position we have already have something, so we will move on, and if we don't, we will add a node here and create a node here. Okay, so and so on. And now we will create a node for O, and then we'll create a node for D as well. So here, as we can see, when we add word code, we will add this. When we add word coding, we will add I as well in this. So that's how we will keep adding the nodes, and whenever we reach to the end of the any word, we will set ends with value to the true. So that's how we will be doing it. So now let us see how we can search inside our try. So to search inside our try, we have created a try now, but what we need to check, firstly we will check if the root for example, we need to search code word inside, we need to search coding inside this. Okay, so what we will be doing is we will check if the children of our root has value C in it. Yes, it has value C in it. Then we will check if the children of C has value O in it. Yes, it has value O in it, and so on. We will keep checking the children, if their children have their values, and if all those values are present, we will say yes, it is a yes, it this word is present in inside our try. And when we reach to our last value, we will also check if this value, that's why we have created ends with variable, if this value ends with a true. So if this ends here, so that means that we have the word coding inside our try. And another thing, if we have to check prefix, we will do the same thing, but in this case we will not check any ends with, we will just check if we for example, we need to find app inside our if anything starts with app, so we will check if the children of root has A, and then we will check if children of A has P, if children of P has P, then and that's how we will check if this word exists inside our try or not. So let us quickly jump to the code, and it will clear everything. So first of all, we want to have nodes inside our tree. So let's create a structure for that and call that try node. Okay, so now we will have three things inside it. First thing will be the value, the character we need, which is basically whatever we string have, we have characters in that, and for each character we have a node. So and for each node we will have a check if it is the ending, and for that we will create a boolean value, and alternate we will have children of this node, and which will be also a type of node inside and try. And we can have 26 because we have given a constraint here that words and prefixes only consist of lowercase letters in English, so that's why we can do this. And now let us create a function which will initialize our node. Okay, so it will return a node. Okay, and let us call it get node. Okay, so in this function we will take an input of character, let's say is ch, and this we will create a node for this character. Let's say try node. Let us say current node, we are creating a new node, is equals to new try node. Now here what we have, so the current node, we need to initialize it. So we need to initialize all the children of our current node to null. First of all, we will do that. So we will run a loop up to 26, and we'll initialize all the values inside our current node for our childs to null. Okay, now what we will be doing is current node, value of current node would be whatever we have passed inside our function get node. And for now, when we will add the word inside our insert anything inside our try, we will set this if it is the last element for now, initialize everything to false. Okay, so now we have initialized it. Let us create a root. Okay, let us create a root here and say it will be a type of try node and say it root, and let us just initialize this root inside our constructor. So we will say get node, and the value of our root node would be backslash. Okay, so now we need to insert this word inside our try. So let us create let us firstly get a root node, and we need to add the children inside the our node. So let us say run node equals to root. Okay, so what we will be doing is we will iterate over all the elements inside our word. Okay, so let us say char ch is inside word and iterate over it. So now first of all we will check if this character already exists inside the uh, children of our root node. Okay, so the children of our root node are these childs, and we will say character minus a. Basically, a minus a would be 0 and b minus a would be 1. So we will create an array in which we will check if we have anything from a to z inside our child. So if it is not null, if for that means we don't have we already have something. Okay, so if we already have something, we will do nothing. We will say current node is equal to current node child. Okay, we will just move to its child. Okay, so now as we have moved to its child, and now what we will be doing if current node is not null, we have done this. If it is null, we have to create a new node. Okay, so we will create a new node and will assign it to the current node children. So the current node child would be this is equals to what we should say get node. We have created a function get node, and we will use that here, and we'll pass our character inside that. So it will create a new node. For example, we have a string code and we have a root, and so it will add value at its particular position. It add value at index number 2 for C, that yes, we have C now. It will add a new node. Okay, so the C node is added. So now we will move to that node. Okay, now we will move to that node. Now we have moved to the node we have added. Okay, so as we add, and I don't think we need to do anything inside this insert function. So anything else inside this insert function, it will insert value inside a try like this. Yeah, it will insert. So now let us write our search function. So first of all, let's get our root. So our root value, let's put inside the current node is equal to root. And now we will again iterate over the word, and let's say char word. And now current. So what we will be doing here is we will be trying to find if our current node if our current node children contains are this characters. So if a of ch minus a is equal to null, basically it doesn't contain it. So in that case we will return false. So we have an answer that this word doesn't exist, we cannot search it. And if it exists, then we will move to the next node and check next words. So we will move to the right child. Current node is equal to childs of this. So now in next step, what we'll be doing is, for example, we have a word code. First of all, we have checked if C is present. Yes, C is present. So we move to C now. So next step, we will check if in C's children, O is present or not. Okay, if that is present, we will go ahead, and that's how we will find the word. And at the end, if our last word ends with, uh, that is very well we have named it. Yes, ends with. So okay, and we need to set. Okay, one thing we may have missed in insert, we have not set it the end with. So whenever whatever is our last node, we will need to set it ends with to true. So that will tell us that this is the last word, or this is the last character of our word. So here we will check if this is the last character of our word. Yes, we have found the complete word. And if it isn't the last character of word, we have just found the prefix. We didn't found the word. Okay. And similarly, we will write the same code inside our search prefix. The only difference would be we will just return current node. If our current node is not null, that is our answer. Basically, if current node is not null, we will return true, and else we will return false. So that is the code for it. So, and I hope that makes your intuition of this very clear. And let us just run this and try if we have written the correct code. Okay, so we have some compilation error. Let me just correct the compilation error and get back. So we have just done few spelling mistakes and a few semicolons were missing, and now I've run it. It is accepted. And one thing was missing, that we need to return our current node as well. We need to get the node, so we need to return it. And I was missing this return statement. So let us just submit it now, and it is accepted. So that's it from my side. Thank you so much for watching. I hope this helped you.